Yay, hello! Yeah, right, I'm Anastasiia, and I talk about mobile security for the last few years. But this talk will be a little bit different. Instead of discussing some discrete methods, we will talk about real-world application, about understand its risks and threat model, and we will create a security system where most control is in our hands, as us as mobile developers. And no failure of server will introduce new risks in this model. That explains a bit the name of my talk. But be brave. It's security talk. It may be a little bit complicated. OK, so why should we think more about security? You know, our users, they live in a kind of magical world where things just happen, and they think that they are safe out of the box. But sometimes, well, remember Pegasus? Like remote jailbreak where just pressing a link. Pegasus is a rare bird, and we can nothing do with it. But it doesn't mean that we shouldn't pay efforts on implementing security in our apps. Because without implementing a proper security strategy, attackers won't need Pegasus. They will grab data from our application in a much more easier way, right? And most users trust sensitive data to our apps, regardless on how well we protect it. So it's up to us to build a right security system. But security guys tend to look on the world through the lens of security, and most security talks, they pay attention on some methods, assuming and seeing our mobile application as a spherical cow. And security itself as a set of rules. Do these, don't ever do that. It's not exactly so. We are not growing spherical cows, right? We are building real applications for real users, and that's why we need to discuss security in a proper way. While we are building application, we start from user problem and planning application flow, filling this flow with features, and there we are, writing the code. When we are talking about security, it's quite similar. Security starts from risks and threat model and progresses in a similar linear fashion through methods to implementations, to choosing the instruments and writing the code. Note that the most popular question, what library should I use, is the end of the sequence. The statement, it is secure, it's kind of invalid and irrelevant. It's as fake as presenting our application as a spherical cow. Instead, the statement, it is secure against certain threat model and attacker makes a little bit more sense. And from here, we derive all risks and measures. We talked before about trust. So what is a trust model? Trust model is whose secrets do you trust in your system. In our case, it's really simple. Everything is broken. Trust nobody except the user, right? And the goal of this talk is to discuss a real application and to think how to build security in a real one. That's why we need a hero. And we won't talk about Alice or Bob. We need a real hero. Hector, can you please help me a bit? Yeah, that's our hero. Actually, he is our user. Do you have an iPhone?
Yes, I do have an iPhone.
And as soon as Hector will install our application, he has some trust to our system. And basically, you must have some sensitive data to protect, like passports or maybe some private photos.
Maybe.
And of course, you can imagine a password. Please imagine some password.
Okay, hashtag Heck4 is the best.
Awesome. It's better than 1, 2, 3, 4, 5. But Hector is a little bit, a paranoid user. He wants to protect his data.
They're watching me.
He's like wearing a tinfoil hat.
I feel safe now. The government's not watching me anymore.
And we will create application for users like Hector who wants to protect their data. Thank you. So what is our application about? It's yet another travel application. When you have passport or insurance, you usually have the backups when you're traveling somewhere, and you want to store these backups in a safe way, right? So we will create an app for that. This is the app architecture. User takes photos, app sends these photos via network on the server, and server storages photo on some storage. It's really easy, and this is a threat model. Well, not a very detailed one, right? We can imagine much more possible threats, like this. Really lots of them. Remote jailbreak or rubber hose cryptanalysis. But unfortunately, we can't handle them all. Let's leave only those threats which are in our control. This is how they look like. T1 and T4 means the data may be stolen or changed. T2 means the network may be intercepted. T3 means the network may be intercepted and data may be redirected. For every threat, we will create a countermeasure. But let's do it like one by one. So, T1 and T4. It's about attacker who tries to steal data or to tampers it. You can do it easily on iPhone using applications like iPhone Box. If I remember correctly, it was working till iOS 9.3.2, probably. On the server side, it's even easier. What should we do? We should encrypt users' data using symmetric encryption. So the user has some secret, and we encrypt data using this secret. And if user wants to decrypt data without knowing a secret, he can do this. Or at least he can't do this without a trace. Threat T2 is passive man in the middle, where attacker collects data during transmission. It's easy to emulate using proxy like chars or burp, but it's also easy to do in a wild. As soon as we're talking about transport, we mean asymmetric encryption, right? To ensure the identity of both parties talking. However, it's much safer to use asymmetric encryption to derive only one temporally symmetric key. You know maybe the term perfect forward secrecy. It means that the data is being splitted by sessions, and for each session we derive temporal key. And if one key is leaked, you can decrypt only data in one session. You can't decrypt it all. Threat T3 is active man in the middle, where attackers not only intercept the traffic, but he also redirects it and pretend to be our server. As example, we can name China with their golden shield firewall, which is able to compromise SSL connection using fake SSL certificates. And again, we are talking about asymmetric encryption. But this time, we are talking about asymmetric encryption with certificate pinning. I think you have already implemented SSL pinning in your apps. Yes, please raise your hands. Who has implemented SSL pinning? Well, almost a half. For those who still don't implement SSL pinning, it's really easy. The idea is that app stores public server certificate inside, and on every network connection, it compares stored certificate with the one from the server. If certificates are different, app rejects this network connection. Let's show our protection methods on a map. Well, this is symmetric cryptography, asymmetric cryptography with ephemeral keys, asymmetric cryptography with certificate pinning. And it's all about encryption. Encryption means keys. Keys means trust. Let's recollect our trust model. Whom do we trust? Only the user. Okay. Going back to our app, users take photos and put it inside app. App encrypts it using symmetric encryption, wraps into container. Then application and the server initiate secure session, agree on ephemeral key, and wraps container into this key, application sends it to the server, server unwraps container, and then stores encrypted photo on the storage. Please note that we store on the storage only encrypted version. By the way, there is one component I haven't talked before on the scheme. There are cases where there is no trust between client and a server, or client and a transport, or all these things. There are a method to verify server honestly, even if all cryptography fails. Zero-knowledge proof. Zero-knowledge proof is a simple mathematical protocol about comparing some pre-shared secret between two parties. The idea is that two parties never transmit this secret via network, neither the secret itself or any hashes derived from this secret. ZKP will help us to ensure that server actually has our data. You can read more about ZKP in that awesome blog post, Zero-knowledge proof protocol without magic. Or you can ask me, and I will tell you everything about it. But it's really easy, just easy mathematical thing. So, going back to a data model, what we do have? We have a password in user mind, and we derive a secret key from this password using KDF. KDF is key derivation function, is another easy mathematical function. It's actually a way to create regular string to a cryptographically strong key. What we also have, we have photo. Photo itself is a sensitive data. It should be private, so we will encrypt it. And we have two pieces of metadata. Metadata M1 is basically timestamp plus CSC of the photo. Metadata M2 is the name of the photo, so application will ask user to put the name of the photo. These metadata are public, and we will use them for additional checks. Also, both app and the server, they generate a key pair, private public keys. And remember that application has public server key inside. This is how they look like on the scheme. The real password is only inside user's mind. Then we have secret key, sensitive data, two pieces of metadata, and of course, mobile key pair and server key pair. And this is the key hierarchy of trust. Everything is being derived from the user secret. We use a password to derive user secret. We use user secret for symmetric encryption. We also encrypt all keys into some symmetric container, and then we use these keys for transport layer encryption. So everything actually is being derived from the password. Let's see the application flows. Next slides will contain some pseudocode. So to make it more easier, I use the crypto primitives from Themis library, but they're just easier to understand, like secure cell is thing for symmetric encryption to generate these symmetric containers. Secure session is thing for transport encryption, and secure comparator is the ZKP protocol implementation. You can use any library that you prefer. However, as much as I am aware, the only ZKP implementation on iOS is inside Themis library. So let's start one by one. Sending photo on server. Stage 1 is preparing the data. Application asks user for the password, generates secret key from this password, encrypts photo, and stores it, grabs the metadata, asks user to provide the name of the photo, and stores it. Removes from memory the original photo, of course. Then the transfer data. Application starts a secure session connection to the server using own private key and server public key, and sends encrypted, application and server derive one temporally ephemeral key and use it to encrypt already encrypted container and to send encrypted photo and metadata on server. After that, after receiving OK from server, application terminates session, which means that next time user will want to send another photo, we will start another session and generate another temporary key for it. So we terminate session and mark all this data as thing on our side. Only 8 simple steps. Reading photo from server. It's still easy, come on. Reading photo from server. First step is also starting a secure session connection. So we started using private key of the app, public key of the server, and on the second step, it's kind of trickiest part, because application need to be sure that this server really contains the photo. It starts ZKP procedure with the server. Basically, it sends metadata M1 to the server and asks server to prove that it has metadata M2 without sending this metadata through the network. What does it mean? That application sends timestamp plus CSE to the server and asks server whether it has the name of the photo. Server should prove that it has the name of the photo without sending it using ZKP protocol. Only if this proof is success, application will ask server to send the photo. Because if this if ZKP fails, it means that server can't prove it has photo. So basically, we shouldn't continue. When application receives photo, it remembers that the photo is still encrypted. So it asks user to provide user password to decrypt the photo. And at last, show the photo to the user. 7 easy steps. Okay, there are some ways to make it even more tough. For example, using not one password for application, but one password for every photo. Or maybe doing transport layer encryption, adding more checks to the transport layer. I can tell you about methods to make it more tough during office hours. Also, I can tell you about possible worst case scenario attacks also during office hours. What should we remember more? Apple actually enforces good security practices for us. all you know about new Apple transport security things. We need to use HTTPS almost everywhere. We need to drop all ciphers and all these things. Take a look on these links. There is an awesome blog post by Nabla Code explaining what exactly you need to change in your system to make it work. And of course, you know all the new requirements for privacy settings, for accessing the contact book, HomeKit, HealthKit, and you know what will happen if you don't provide these keys in a playlist, right? But there is still a link for that. This is a slide from Black Hat conference, where Ivan from Apple told some serious security things. I would recommend to everyone to read the slides. It's kind of hardcore security slides, and to watch the video. But what I want to point out is that Apple actually follows the same principles as our talk. Derive user trust from the password. Right? So the key points. User trust is quite simple to implement. 8 steps, 7 steps. And it's simple and kind of complicated to hack. But it will happen only if you think about security as a whole system and starting from risk models and threat model, not as a set of separate methods. Maybe you will need to reread the slides thinking about your new application. Maybe you will want to reread my other slides where there is like simple ideas about perfect forward secrecy, SSL pinning, ZKP, and so on. Maybe you want to watch latest WWDC video. As you see, just in last year, there are 3 videos from WWDC about security and privacy. Apple really enforces us, right? And maybe you want to read those awesome blog posts about Apple transport security, about privacy settings, about ZKP, or maybe about Pegasus spyware. Anyway, if you have any questions about building security, about adding security in your applications, or even what library should I use, just ping me, okay? Thank you.